Okay, so in this video, I will show you how you can create this type of wall destruction with the help of Houdini. And you can completely do this thing in the non-commercial version of Houdini. If you don't know the difference between the non-commercial and the commercial one, basically you can use this thing for your own personal project. You cannot do any kind of freelancing or this type of things with the non-commercial one. So first of all, we need to create the wall. So I'm just using this grid node and I'm just changing some parameters there of the size and these things. You can just copy the settings. You don't have to copy. It's kind of your choice. So I want my wall to be this bigger in size. So that's why I'm just using this 4.2 value. If you increase or decrease this, it will increase and decrease the length of this thing. Then we have to use a transform node because we need two things. Right now this is kind of a thin plane. There is another option called cube. You can also use this cube option, but I will show you how to convert this thing into a cube. So we are using two transform. First one is this one and second one is this one. So I'm just shifting this thing kind of just a bit back, and then I'm merging this thing. Then I'm using a unwrap node, and then I'm using a poly extrude. So after using the poly extrude node, you can see the thickness. So if I just enable the, yeah, now you can see properly. So basically that's the thing. And the UV unwrapping is basically for the UVs, because when you do the destruction and everything, the UVs are kind of very messed up. So you have to use this node. You don't have to change anything, just put this thing there. Then I'm using an ISO offset just to get this type of volume, and then I'm using a scatter node. Right now the ISO offset is kind of very high in resolution, not high, I mean low in resolution. You can see this is very low. You can just increase the uniform sample and it will kind of become denser. After that, you have to just scatter your points on that surface, because if you're not using the ISO offset, if you scatter the point directly without this node, it will just scatter the points outside the geometry, not inside. So in order to put the point inside the geometry, you have to use this ISO offset. And then after putting the points inside, we just have to merge this thing with the box one. Okay, so the reason why I'm using this thing, so basically what I'm doing is I'm kind of fracturing. I need more points in the center compared to the outside one, so that's why I'm using this box node. It will create a box there in the center. Then I'm doing the same thing, ISO offset. You can increase the resolution, and then I'm scattering this, and I'm just increasing the overall point 600, and in this one I'm using 50. So basically I'm just doing the more fracturing inside in the center area and less in the outside, and that's why I'm using this thing. You don't have to use this one. You can just directly add more scatter points in this thing, like 100, 200, 500. So the more you increase this value, the more fracture you will get. And what I mean by the fracture, you have to use this RBD material in order to fracture your material. So just add this node, and then you have to connect your main poly extrude, your main mesh, to the first input, and the last one to your this scatter one. And in this RBD one, you have to just increase this input point, or else it will not gonna get the scatter points of these things. So after that, you will get something like this. It will scatter everything. If you press W on your keyboard, it will show you the fracture of this thing. You can see we have this type of fractures all over the mesh. Then we are using the RBD pack to pack everything. And in the RBD pack, you don't have to change anything. Just connect this to this too. And then I'm just doing a UV auto seam. This is because the UVs will be messed up, and in order to fix that issue, we have to use this node. So just add a UV auto seams node there, then use a UV flatten, and in this one you can just copy the settings. Basically you don't have to change anything. You just have to select inside there in the group section inside, and that's it. Then you have to use a UV layout option, and in this one also you have to select inside, and in this one also UV auto zoom. Then you have to connect this one to this and this one to this. Make sure that the connections are proper, or else it will not going to work properly. Then we are using another merge node. I'm putting bricks inside the two walls. You can see we have this bricks. So I'm just I don't know if it is visible that much or not, but yeah, you can see there it is there inside. So if I just go to this one, there is no bricks, and if I click on this, we have bricks. So in order to add the bricks, you have to just use a box like this, scale it down like a brick in this area. You can see there, use a copy node, just increase the total number of numbers of these things, and use the translate value to kind of change the location and this type of things. You can see there, do it like this, and then use another copy node, and this time we have to use it for the up z direction. Just increase the translate value of your z like this. Then after that, you just have to assemble this like this. So now you can see individual bricks, and make sure that you also select the inside and output prefix is bricks, and you can just copy these settings if something is not checked or anything like that. Make sure this one is checked. Then you have to use a connect adject piece to connect everything, so it will create constraints for your simulations. So constraints are the important thing in order to get realistic simulation of fractures and those destruction and those type of things. So that's why I'm using this connect adject piece. Then we have the constraint one. You just have to add this node. You don't have to connect anything, just the middle one. So basically the pink one is for the constraint. You can see their constraint geometry input, the text. Then you don't have to add this null. It is not necessary. Then you just have to connect this thing to your RBD pack. So whenever you do any kind of RBD simulation, make sure that you pack your thing because it's important. You have to pack your geometry and then you have to do the simulation on top of that thing, or else it will not gonna work. So you have to do the RBD pack in this one. So we have two RBD packs there. Then we have to just connect this one to our merge, and we are merging both of the wall and the bricks together. Then we have to unpack this in order to do the simulation. So now you will think that if we are unpacking the RBD, even why we are packing these things in the first place. So one of the most important reason would be like we have three different types of output. We cannot connect everything into a merge node like this. So in order to make the three connection into one connection like this, we use RBD pack. So by this option, you can just merge multiple walls, multiple bricks, multiple glasses, and whatever. If you have a very big building or anything like that, you need to merge all of these things together. In order to merge them, you need this RBD pack so that you can get this single output and you can connect those output with your merge properly. Basically, that's the use of the RBD pack. So in order to get the access of the pieces, we have to use this RBD unpack. Then we have to use this RBD configure. Then we have to use a bullet solver there. And then we have to pack this thing again. Just pause the video and make sure that you follow this thing properly. The last option is this static one is for collisions. So if I show you the collisions, not for collision, the active and inactive point. So in my case, I just want to kind of affect the center portion of the wall. I don't want to include the left and right one. So I'm just using two box node. I'm merging them and I'm connecting this thing to this one. So now it will not gonna affect the left and right one. It will just affect the center one. Then I'm using this RBD solver. So this is the main solver for the simulation. And then you just have to connect this three nodes like this. Then we have the this one collision geometry one. So for the collision geometry, I'm using this test geometry crag. This is default one. So if you just press tab and search for crag, you will get this test crag thing, and you will get an animation also. I'm just transforming this thing to my wall so that, okay, so it will be heavier. You just have to connect this thing to this. And in the constraint one, you can just copy the settings, glue threshold to 1. I don't have any forces right now. You can see there. So it is just affecting the center part, not the left and right because of this thing. So in the RBD solver one, you can just copy these settings. Basically, you don't have to change anything. Instead of this collision geometry, I don't think so you have to change anything. Force also is same. I think in the glue one, you have to select this glue. You have to type this or it will be already there. Then in the guide, you don't have to do anything. Advanced. Nope. You don't have to do anything. You just have to change the value of the strength later because the constraint will be so hard that the force of this character will not gonna affect anything, so your destruction will not gonna happen. You have to decrease your constraint strength, your glue strength. Just decrease this number if nothing is happening, and after decreasing this you will see that it's kind of doing the things. After that, just use RBD pack, and then we have to cache this. So after the cache, we have this type of simulations, you can see. So the wall destruction is done. Now we have to do the debris. For the debris, you just have to get your file cache there. I will just remove this. You don't need this thing because we already did this UV auto sim thing in this area. so you don't have to do anything right there. So you just have to use a null there just to make things cleaner. So I'm just using this null. You don't have to use this thing. You can directly connect this thing to the RBD unpack. This is the most important thing. You have to use this RBD unpack. If you're not using the RBD unpack, your debris will not gonna work properly. In order to get the debris, you have to use this debris source. So if I just show you, you can see there we have some sort of yellow dots, and these are the debris of our simulation. If I'm not using this RBD unpack, it will behave very weirdly. Then just use this source one and just try to follow or copy these settings. Density to 50, enable these two options and make sure all the options are kind of enabled like this. You can just copy these settings and nothing more than that. Then we have the add tree randomize option. I'm using this thing for random kind of scale of the particles, because if you're not using this attribute, then the debris size will be similar and it will be same. So it will kind of, in reality, you will not gonna say you will not gonna have same size of debris everywhere. So in order to give the size variation, I'm using this p scale. So you just have to write this p scale, change some value there, 0.4, 1.5, and that's it. Then we have the attribute randomization in the normal. Just use normal just to give rotations, random rotations, and that's it. Then I'm using a copy point to copy these pairs. Mountain node just to give this type of debris shape. Then using normal, and then I'm just using copy point to spread all the points in the debris source like this. Then using a DOP-net. So DOP-net is the important one. So in the DOP-net, we have to select the RBD packed object. First of all, you just have to add this nodes: RBD packed, rigid body solver, pop source, static, ground, merge, gravity, multi-solver. That's it. Add this thing first, and then you can connect everything like this. Multi-solver, make sure you connect with the RBD packed, rigid body, pop source, static object to the merge node like this, and make sure the connections are kind of proper. Always make sure that your static object is in your left side, and in order to make it left, you just have to drag this thing like that. So now you can see this is in the right side. You just have to drag it up, so it will be in the left side. So the first one is you have to just select the first context geometry there. You don't have to change anything in the RBD packed. In the rigid body solver, you don't have to change anything. Pop source, all geometry, use first context geometry, birth rate to 1000, and you don't have to change anything. Multi-solver also, you don't have to change anything. Static object is basically your collision. So this one is my character collision. Copy your collision. So this is our collision, not character, the wall destruction one. You can also add the character, but I'm just using the wall destruction one. So you just have to add a null there, copy, control C this, go to your DOP-net, select your object and paste your value to your swap path, and you can enable or disable the geometry also. So you can see we have this character there. Okay, no, you don't have to copy this one. Sorry, I'm so sorry. You have to copy your character, this one. This is my character. You have to copy this. Then yeah, you just have to add the ground plane so that your points can be collide with the ground. Then you have to use a merge, gravity, and that's it. And in the static object, you can leave this thing to the surface collision. So after that, you have to use the DOP import net. You have to just control C this and control V this thing to your DOP network so that this thing can connect together. And then you have to just connect a file cache like this, debris one, and then you have to cache it. So you will see something like this. You can see everything is colliding properly. So in this setup, the debris one, the most important thing is to unpack your RBD. If you're not using this one, it will behave very weirdly. So after that, we have to do the smoke simulations. So for the smoke simulation, I'm using the same thing, debris source thing. So I'm just getting this debris source. It will be slow. So you just have to use the same thing, debris source. Then you have to use the PopNet. And in the PopNet, you don't have to add anything there. So if you just search for PopNet direct, you will get this PopNet thing, and you don't have to change anything. You will get all the nodes in the stuff there. You just have to add gravity so that it can fall down. So in the source input 1000, you don't have to change anything. Points, use first context geometry. In the attribute also, you don't have to change anything, and that's it. Then you have to use a pyro source. In the pyro source, you have to use these two variables. Just press on add, select density, and this one I will show you, density and temperature also, two separate things. Then you have to use the attribute noise to give some noise variation. Select your density and temperature from this drop down value. You will get your density and the temperature there, and just give some value there, amplitude and p value and this type of things. Enable animation, and that's it. Then you have to use a volume rasterization And this one, attribute your density, temperature, velocity, and then you will get your volumes and enable these things. Just copy these settings. Then in the pyro solver, in the voxel size, you have to just copy this thing, copy parameter, go to your volume rasterization, paste relative reference. So whenever you change the value of this thing, it will automatically change it to this area also. And you have to make sure that the values are kind of same in both of them. So that's why we are copying the points. And the this thing, you don't have to change anything. You can make this thing SDF, volume velocity, copy this. Sourcing also, just copy these things. This is the temperature one. You can copy this one also. Dissipation, shape, buoyancy reduced to -1 because it's kind of a dust thing. So that's why we are using -1, or else it will kind of float up like a fire thing. We want the dust looks, and you can just copy this setting. Disturbance, turbulence, and this type of things. Just pause the video and copy. Just disable everything. Make sure you just enable the density. It will reduce your file size. Convert to VDB. Use 16-bit float. This things needs to be turned on because of the optimization thing. Then use a file cache and cache your simulation, and you will get something like this. This is your smoke simulation. You can see there we have this output also for the collisions. So in order to make the smoke collide with your object properly, you have to use this object merge. In the object merge, you can see I'm using the geometry. You just have to go to this one. Just copy this, Control C in the object merge, Control V, paste. So it will get the access of this node there. And then you have to just use a VDB from polygons. Similarly, I'm converting the polygons to VDB of this crag also. So you can see this is volume. And now you will think that why we are doing this, because of the collisions. In order to get the collision proper, we have to do this VDBs things. And then I'm just merging this thing, and then I'm just file caching everything so that it can run fast. And in the pyro solver, that's why we are using this SDF volume velocity. Decrease the velocity scale to 0.3. By default, it will be at 1. So just make it 0.03, and that's it. File cache everything, and you're good to go. Now, when everything is done, our simulation, smoke simulation, debris simulation, and the wall destruction, we have to merge everything together. So I'm using this same thing, object merge. So the first one is our wall, the second one is our character, the third one is our debris, and the fourth one is our plane. And then I'm just merging everything there, so it will show everything at once. Then I'm using this material node for the rendering purpose. So I will make the rendering thing later. So if you are interested in the rendering portion also, then let me know in the comment. I will make one video for that thing also.